Hello and welcome to your preview of Training to Go modules presented by Technical Sales and Consulting. This preview covers types of insulation tests. It is extracted from our test equipment and insulation theory course. At the end, we will provide how to access more information about our training products. Thanks for visiting, and we hope you enjoyed the preview. For more information, visit our website, trainingtogo.net. There are three basic types of insulation resistance tests. Short time readings usually are 60 seconds in duration. Time resistance tests, which include dielectric absorption, or DAR, or polarization index, or PI. Lastly, there are step voltage readings, which are mostly used for DC overpotential testing and can be used at insulation resistance test values. We'll spend more time on each of these. A short time readings test is the most common insulation resistance test. It is sometimes referred to as a spot reading. Let's look at this curve to understand what is being measured. The y-axis is megaohm. The x-axis is time. Notice the limitation of 60 seconds as the maximum time. To measure, simply connect the test device across the insulation and operate it for 60 seconds. The resulting value is then read and recorded. Some specimens will max out the meter after a few seconds. The test can be terminated once this occurs. Note that at 30 seconds the value will be less. Keep in mind that temperature and humidity, as well as the condition of the insulation, will affect your reading. Here are a few other important considerations. As a general rule of thumb, insulation resistance should be approximately 1 megaohm for each 1000 volts of operating voltage, with a minimum value of 1 megaohm. This is what is known as the 1 megaohm rule. For example, a motor rated 5000 volts should have a minimum insulation resistance of 5 megaohm. In practice, megaohm readings should be well above this minimum value when insulation is new or in good condition. By recording these measurements over time, you gain a better basis of judging the actual condition of the insulation. Any persistent downward trend is usually a warning that there's trouble ahead, even though the readings may be higher than the suggested minimum values. Periodic readings found to be lower than recommended values may be okay as long as they are consistent. Refer to the ANSI/NETA maintenance testing specification for recommended insulation resistance levels in the absence of manufacturer standards. Now let's look at some other insulation resistance tests. The first method is dielectric absorption ratio, or DAR. In this test, the testing device is applied and IR, or insulation resistance measurements, are taken after 30 seconds and 60 seconds. The test is independent of temperature and volume. The dielectric absorption ratio is calculated as DAR equals resistance at 60 seconds over the resistance at 30 seconds. The test can provide conclusive results as to the condition of the insulation. The test involves recording the 30-second reading first, then the 60-second reading. Then you can compare the resulting ratio to this table. Results between 1.0 and 1.25 are considered questionable. Ratios between 1.4 and 1.6 are considered good, and anything above 1.6 is considered excellent. The term Gill has been coined and named after Paul Gill, the author of the book entitled Electrical Maintenance and Testing, and used as a gauge to evaluate the condition of the insulation. A reading below 1.25 gills is cause for further investigation. The next time-resistant test method we'll examine is the polarization index. It represents the ratio resistance values of 10 minutes over 1 minute. Here is the formula. PI, or polarization index, is equal to IR, or insulation resistance at 10 minutes, over IR at 1 minute. It is based on the absorption effect of good insulation compared to that of moist or contaminated insulation. You simply take successive readings at specific times and note the differences in the reading. Tests by this method are sometimes referred to as absorption tests. Note that good insulation shows a continual increase in resistance as seen in curve A over a period of time in an order of 5 to 10 minutes. This is caused by the absorption current we spoke of earlier. Good insulation shows this charge effect over a time period much longer than the time required to change the capacitance of the insulation. If the insulation contains much moisture or contaminants, the absorption effect is masked by a high leakage current, which stays at a fairly constant value, keeping the resistance reading low as you see in curve B. As we did with the DAR numbers, we can compare the polarization invoice numbers the same way. A value of less than 1 is considered dangerous. A value of 1 to 2 is questionable and should lead to further investigation. A value of 2 to 4 is good, while values above 4 are considered excellent. The step voltage test uses different voltage settings during the resistance testing. In this test, each test voltage is applied for the same length of time, usually 60 seconds. Each test is then recorded and placed on a graph in order to compare the values as seen in this example. By applying increasing voltages in steps, the insulation is exposed to increased electrical stress that can reveal information about compromises in the insulation, such as pinholes, physical damage, or brittleness. Good insulation should withstand an increase in overvoltage stress, and its resistance should remain approximately the same during the testing with the different voltage levels. On the other hand, especially at higher voltage levels, deteriorated, cracked, or contaminated insulation will experience an increased current flow, resulting in a decrease in the insulation resistance. This test is independent of insulation material, equipment capacitance, and temperature. It is advisable that this test be performed only after an insulation spot test has been inconclusive. A spot test deals with absolute resistance change in a single reading with respect to time, while the step voltage test looks for trends in resistance with respect to varying test voltages. In this example, we've chosen 3 voltage steps. At 250 volts, you will notice the resistance increases. As we step up the voltage, we would expect the resistance to decrease as we see at 500 volts, and the sharpest decrease occurs at 1000 volts.
Hi, we hope you enjoyed the sample video of our online e-learning module. This clip is from one of our many available modules. We are always working on new modules. Here is the current list of developed lessons. Did you know that 16 of our courses carry 22 NETA CTD credits, and we have courses suitable for Pennsylvania and Delaware CEU credit? New modules are being constantly added, so check back with us on our website trainingtogo.net. Let our Training to Go programs train your people while you run your business.